Hi everyone, it's Rohan this side, and I welcome you all to the new video by Lemniscates Academy, where I'm going to solve the entire paper 3 that came in October-November 2024 session of Cambridge examinations. The subject code is 9709. The variant of the paper is 2. Now, throughout the whole explanation of every solutions, I've made sure to first explain the concept behind that question and tell you the whole procedure of how you can solve it step by step. And after that, I'm going to perform the solution because I know that P3 can become very tricky for the beginners. And to simplify it, I first explain the concept and then the solutions. So yeah, just make sure that you are enjoying this video in terms of getting most out of this video. In case of any kind of doubts, please make sure to comment them and I'll reply to you as soon as possible. So for your first question, it is given that we have to expand this 9 minus 3x, which is having a power of half, in ascending power of x up to and including the term in x square. So that means that I want to have a constant value, then a term in x, and then the term in x square. We also need to simplify all the coefficients that we get during this expansion. So if you notice over here in this given bracket that we need to expand, the power over here for the bracket is half, which is not a positive integer. So you cannot apply the formula of what you have learned in P1. For this, we'll be requiring the formula that you have learned in P3. That is, when n is any real number, then you can use this formula. But then there is a restriction that you must have the constant term being 1, not 9 or some other number. So it is mandatory for us to go from this format into a format where I can obtain 1 in place of 9. And for that, I have mentioned the concept that is required to solve this question over here in red. That is, let's say in order to expand a plus bx to the power of n, where n is a real number, in that case, if you want a to be 1, what you can do is you can take this whole bracket as the common bracket, which is having a power of n, and then just take a as a common factor out. So in that case, what you're going to get is from a, if you take a as a common factor, you're left with 1. In bx term, you don't have any a, so you need to divide bx with a to get that uh, thing. That is basically if I multiply my a with my b over a, the a and a gets cancelled out and I'm left with bx term. So in a way, this term and this term is exactly the same, but it's a different way of writing it. Now, because a is also sharing the power of n, I can open this long bracket and distribute the powers amongst the two different terms that we are having inside the bracket. So a is going to have a power of n, 1 plus b by ax is also going to have a power of n. So now because a power of n is nothing but 9 to the power of half, it is just a constant term. The main thing is 1 plus b by ax to the power of n. And now because we are having the constant as 1, we can now use the formula that we have learned in the P3 to expand this bracket. Okay. And the formula that we know over here is that 1 plus kx to the power of n can be written as, my first term will always be 1. The second term will be n multiplied by kx. And the third term would be where I need to get my x squared term. So over here it will be n into n minus 1 divided by 2 factorial into kx square. Now how do I know this formula? Obviously with a lot of practice. But that's in just any case, if you're not able to remember this, then this information is also provided in your MF19 booklet. You can use it and get the formula right over there. But I always recommend to have your formulas on your fingertips so that it's going to save a lot of your time. And over here, as such, expansion for this, or I should say the validity for the expansion is not asked over here, right? But still a good student is always going to mention about the validity for this expansion. And the way that we do is we just a quick hack over here is just to have modulus of x less than something over here. Okay, so this will be value when you get 9 minus 3x is equal to 0. So 9 minus 3x is equal to 0. If I write, I'm going to get minus 3x is equals to minus 9. My x will be equal to 9 by 3, which is 3. So you can say that in this case my value is going to become simply modulus of x less than 3. It's going to be valid for that. So I also given formula for that. Even though for this question it is not required, but a good sign of a student is just to mention this in the expansion. Anyways, with this given, let's start the given question. So we are having a to the power of n. In our case, a is 9. So 9 to the power of half is 3. And then we are left with 1 plus b by a. So b is minus 3. Minus 3 and a is 9. So I'm left with 1 by 3. And I'm going to have a negative sign because of this negative sign. And then 1 by 3. And then there is an x. And this is having a power of half. So now you can see that the value of k becomes minus 1 by 3 to use this particular formula. So I'll just keep 3 outside of my bracket. And inside the bracket, I'll have my first term as 1. The second term is n into kx. So half into minus 1 by 3 into x, which is minus 1 by 2 into 3 is 6. So minus 1 by 6 x. And then I'll need to take out my calci now. And over here I'm having n. N is what, half? So 0.5 into n minus 1, which is 0.5 minus 1. N into n minus 1 by 2 factorial. And if I do this, I also need to multiply this with k square x square. So what is k? K is minus 1 by 3. So what is minus 1 by 3 square? If I do it, and if I get the square over here, I'm going to get minus 1 by 72. So minus 1 by 72 is the complete coefficient of the x square that I'm getting over here. And therefore, I'm going to state over here that minus 1 by 72 x square is what I'm going to get. And then if you want, if you're asked to get, let's say, we need to expand till x3, x power of 3, x power of 4, you can keep on getting more terms over here. But for now, we are done. I'll just write plus dot 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 because I don't want to go any further. Obviously, there are more terms, but I'm not writing over here. Now, 3 into 1 is 3. Then minus 1 by 6 into 3 will be 1 over 2x. Then what is 3 over 72? Let me check. 3 over 72. It gives me 1 by 24. But now there is also a negative sign. So minus 1 by 24 x square. And this is what you can get as the expansion of this specific uh, bracket to the power of half. Okay, and then let's, if you want to mention about the validity of this expansion, you can say that expansion is valid for values of x that is such that modulus of x is less than a by b. In this case, 9 by 3. But I'm going to take only the positive sign because of the modulus sign. So 9 by 3 is 3. Or in other words, this is same as writing from negative 3 to 3. So either way is fine. So if your x will be any value in between this values of x, this validity is going to be hold true. Basically, this equation is going to give you approximately correct answer as compared to what you're going to put it over here and directly get the output without using the expansion formula. Okay, so all these kind of concepts are pretty simple that we know in the binomial expansion, and I hope that this answer has given you some sense of how you can solve this. Now for the second question, in the first part, we are asked to sketch a suitable pair of graphs and show that the equation cot 2x equal to sec x has exactly one root in the interval of 0 to 90 degrees, or in other words 0 to pi by 2 radians. And for this, the concept that is required is, obviously you need to know the basic graph of cot x that is going to be given on the left side. I'll just mark it. This is for cot x and this is for sec x. So if you're aware about the basic graphs, then plotting these two pair of graphs is pretty simple. And let's say, for example, in examination, you are forgetting about how the graph is going to look like. And even if you're not aware about the shapes, then what you can do is you can just plug in. We know that cot is same as writing 1 by 10, right? So what happens to the output when you are closer to 0 but towards the positive side? So if I do 1 by 10 of some number like 0.000001, you will see it's a very high positive number. Then see what happens at 90 degrees. Then see what happens just before 180, that is 1 by 10 of 179.9999999. You will see a very negative number. So it basically says that the value is approaching from the positive infinity to the 0 and then to the negative infinity. And then you will recollect that yes, I have seen this kind of a graph somewhere, and then you just need to repeat this kind of a pattern. And for the circuits, you can do exactly the same thing. See what is happening at 0, see what is happening at 90, see what is happening at 180. If you are getting some kind of an error, it basically means 1 by 0 does not exist. So division of 0 error is what you're going to get in your calci. Okay, that is basically your infinity. So let's say if you're going to plot a number that is closer to 90 but before 90, let's say 89.99999, you will get a very positive number. And at 1 by cos 0, you are going to get 1. So yeah, we know that sec is 1 by cos. So we can plot something like this. And then if I do cos of 90.00001, it's going to give you a very negative number. And then if I do 1 by cos of 180 is going to give me -1. And then if I do 1 by cos of 269.999999, it's going to give me a very large negative number. So I know that this kind of a curve is there. Then if you have looked into the sec-x graph anytime during your learning process, then I'm sure that we'll be able to recollect the whole idea of how you can complete the remaining graph. Now, if you notice, we're asked to draw the set of cot of 2x, not just cot of x, which basically implements this thing that I'm going to compress the values of x by 2. So whatever was happening at 90 degrees is now going to happen at 45 degrees. Whatever was happening at 180 degrees is going to now happen at 90 degrees. So my graph is going to be shrinked because I'm having the stretch factor in the x direction of half because of this. I'm talking about the concept that we've learned in our uh, AS level in P1 in the functions, the transformation of functions. We have learned all these kind of things. So I hope that this kind of concepts are pretty clear in your head. And then now we can go ahead and plot the final graph in between 0 to pi by 2. Note that you are asked to deal with the radians, not the degrees. This was just for the understanding. And now somewhere in the middle, you will be having pi by 4, which is 45. And then if I talk about my graph of cot 2x, it is going to be something like this. Okay, I'm going to have my asymptote at pi by 2 because my asymptote at 180 that I was at pi is now shifted to pi by 2 because of the stretch vector of half. And this 0 is now going to be happening at pi by 4. And if you want, again, you can use the calci. Okay, guys, you can use 1 by 10 of 2 of 0, then 1 by 10 of 0.00001, then you can do 1 cot of 2 of 90. So you're going to get all these kind of things. Okay, not 2 of 90, but 2 of pi by 4. So you're going to get 0 over here because 2 of pi by 4 is pi by 2, which is 90. But anyways, I always recommend that you're having a good concept of the transformation of the functions. Then solving this kind of questions is not that difficult. Okay. So it's coming from the infinity, then it's going to be 0 at this point, then it starts slowly approaching negative infinity. My graph is going to look a bit weird, but I hope it's making some sense to you guys. Okay. One last attempt. Okay. Now about the sec x in between 0 to 90, I know that it starts from 1. Let's say 1 is somewhere over here. And then it just goes up till pi by 2 in the upward direction. So it's going to be something like this. Okay. This is a zoomed in graph, so yeah, please notice that. Okay, so this is the kind of graph that we are coming up with. It doesn't need to be on correct to scale, so I just write not to scale, not to scale. And I also need to label my curves that the green one is my y is equal to sec x, and then my orange one is y is equal to cot 2x. And then if we equate both of them, we can see that there is a point of intersection over there. I can also mark that. This is okay. I cannot see the color properly, so I'll just change the color very quickly. Point of intersection. And the point of intersection is nothing but the solution. So that is your final answer. Okay, guys, this graph was just for you to be aware about it. Okay, this kind of graphs exist, and based on this we have drawn this graph. So if you're aware about these curves, then getting this solution is just a piece of cake after that. Now in part B, we are asked to show that if the sequence of real values were given by this iterative formula, it will be converging. uh, it converges to the answer that we've got in part A. So basically we need to relate this equation with the equation that we are having over here, that is cot 2x is equal to sec x. And that is exactly that I've written in the concept, that you need to rearrange this and convert this equation into this equation. Okay, you might be wondering that why are you not going and let's say choosing a value in between 0 to pi by 4 and then substituting it in over here, then whatever answer we get we again substitute it until we get the convergence. Well, that kind of question is usually asked for 3 to 4 marks. So over here you can see it's just one marker. So basically what you are asked to do over here is just to rearrange this equation and convert it into the format of cot 2x is equal to sec x. So let's see how we can do this. So the first thing I need to know is I can say that this equation as x is equal to half tan inverse of cos x. So now this can be written as 2x is equals to tan inverse of cos x. And now I can take tan on both the sides, so that it's going to become tan 2x is equal to cos x. Now I can just get the reciprocal on both the sides, so that this becomes 1 by tan x, which is equal to cot 2x, and 1 by cos x is sec x. So that is how basically we are getting that this equation is same as this equation. Therefore, it must be converging to the same root as we have seen in the graph above. So that is how you solve question 2. And now for question 3, the square roots of 6 minus 8i can be expressed in its Cartesian format in the format of x plus iy, where x and y are the real and exact values. By first forming a quadratic in format of this x and y, we have to find the square roots for this 6 minus 8i in that Cartesian format. So the concept that is involved over here is that, let's say for example, if you're going to take the square root of 6 minus 8i, you know that it's going to be equal to x plus iy. So now if you take the square on both the sides, what's going to happen is, on the left side the square root is going to get rid of, and on the right hand side you're going to get x plus iy square. So now if you expand this right hand side and compare the real part of this expansion with 6 and the imaginary part of this expansion with minus 8i, then from there you're going to get two equations in terms of x and y, which you can solve it further to get the exact and real values of x and y. And don't forget that your square root, if you're going to take a square, it could be a positive number or a negative number. And that is why we can get two different values out of this. One is with respect to the positive square root, and one that is with respect to the negative square root. So now, based on this idea, let's go ahead and try to solve this thing. So I know that 6 minus 8i can be written as x squared plus I square y square. So I square is minus 1. So minus y square. Then plus 2xiy or 2xyi. Okay, 2xiy or 2xyi. I know that I is the just an iota, so I'll just write 2xy together. And I'm going to compare my real part with real. So from here I can get this 6 is equal to x square minus y square. And from the imaginary part, I'm going to get that minus 8 is equal to 2xy. So from here, let's say for example, I'm making y the subject of formula. So it's going to become y is equals to minus 8 by 2x, which is minus 4 over x. Now I need to substitute my minus 4 over x in place of y over here. And that is I'm going to get the quadratic equation, or I should say quartic equation. Okay, not quadratic. It is written quartic over here. It's my bad. I first read it as quadratic. So we need to form a quartic equation. It will be having the maximum power of x or y as power of 4. Okay. But it's going to be a hidden quadratic equation anyway. So yeah, let's try to solve this. 6 is equal to x squared minus we are having y square. So what is square of 4? That is 16 over x square. Okay. And now we can multiply x square on both the sides. So we get 6x square minus x power of 4, I should say, equal to x power of 4 minus 16. And now let me take 6x square to the right hand side. So this implements that 6x, sorry, let me go back. X power of 4 minus 6x square minus 16 is equal to 0. So from here we are going to get two solutions for the x, okay? And one will be the positive square root and one will be the negative square root. So from here what we're going to do is I'm going to solve this quartic equation in terms of quadratic. So for that I'm just going to take out my calcium and plug in the values to do it very quickly for me. And in that case I'm going to go to mode 5.3, input the a value as 1, b value as minus 6, c value as minus 16. So over here, if I just get the values, I can see that x square is equal to 8 and x square is equal to minus 2. So I can say that x square, let me take my calculus again. This minus 2 will have the root of plus 2, and I guess we had 8, right? Yes, so x square minus 8 is what I'll need to have as a factor. So from this we get that x square is equals to minus 2 or x square is equals to 8. From here clearly we can reject this because I cannot take square root of a negative number. Okay, so I'll just say that I'm going to reject this. Of course I can convert this in terms of iota, but then over here if you can see x is a real part. So I don't want this imaginary solution over here. And therefore I can just go ahead and say that my x will be equal to, what is square root of 8? It is going to be 2 root 2. I can show that to you. Mode 1. I just got a rhyme over there. Anyways, so square root of 8 is 2 root 2. But now because we are taking the square root, we are having plus minus 2 root 2. And now we are just going to say that when the value of x was positive 2 root 2, what will be my output of y? And as opposite to that, when the value of x is minus 2 root 2, what is the value of y? Okay. Once you take the positive value, once you take the negative value, I hope I have not messed it up while saying it earlier. But yeah, the key idea is, first of all, take one of the x values, put it over here, get the y, then do the same thing with the other x values. So over here, I can simply mention that when x is equals to positive 2 root 2, then my y is equals to minus 4 over positive 2 root 2. So if I just do that in my calc very quickly, minus 4 over 2 root 2, that gives me the output of minus root 2. And similarly, when I do x is equals to negative 2 root 2, okay, and it's going to give me y is equals to, so I just have a negative sign over here, and that's it. I'm going to get a positive root 2. So from here, what can we say? That the square roots of 6 minus 8i are, I hope 6 minus 8i was there, yes, okay, and they are 2 root 2 minus root 2i and minus 2 root 2 plus root 2i. So one is the positive square root, one is the negative square root, and that is how you're going to get the answer. It's the complex conjugate that we have got for this complex number to exist. Now for the next question, that is our question 4, we are asked to solve this equation 5 power of x equal to 5 power of x plus 2 minus 10, where we are asked to give our answer correct to 3 decimal places. Okay. So over here, I said in the concept that we can assume that u is equal to 5 power of x and convert the whole equation in terms of u. Then first solve for u, and then we can convert that u in format of x by using the logarithmic terms or the logarithmic rules over here. So for this, what I can say is, I'm going to get u is equal to, my 5 power of x plus 2 can be written as 5 power of x into 5 power of 2. That is how 5 power of x plus 2 is what I get due to the rules of indices. So 5 power of x is u, which is multiplied by 5 square, which is 25. So 25u minus 10. Okay. I hope this is going to make some sense. 5x is equal to 5x times 5 to the power of 2. So 25u. Yeah, it is indeed making sense. Now this is going to become 24u is equals to positive 10. So you're left with u is equals to 10 by 24. And now if I convert my u into 5 power of x, so it's going to be 5 power of x is equals to 10 over 24. And then if I just want to get x down of 5, I can use ln rules. So ln of 5 power of x, due to the power rule, I can bring x down. So x ln 5 will be equal to ln of 10 by 24. The first thing is to introduce ln on both the sides. And on the left side, because x is on the power, I can bring that power down, as you can see. Okay, so I've done 2 steps on the left hand side at once. First, introducing ln on both the sides, and then also getting my x in the bottom part. And from here, I can get that my x is equal to ln of 10 by 24 divided by ln 5. And then because I want to give my answer correct to 3 decimal places, I just use my calc to solve this. And ln of 10 over 24, if I divide that by ln of 5, correct to 3 decimal places, I'm going to get minus 0.544, minus 0.544, minus 0.544, and this is correct to 3 decimal place. So that is how you get to solve this question that is based on logarithms. Now for the next question, in part A, the complex number u is given by u is equal to two complex numbers, one on the top which is having a power of 4 and one in the denominator. And the question is asking us to find the exact value of the argument of this complex number. Now there are two ways to solve this. The first one is the pretty long method, which I won't recommend it because it's only for 2 marks. and the second one is straightforward method. Okay, so over here, because we are having the complex numbers in the format of cos theta plus I sin theta, then using the shortcut makes more sense. If it was in the format of a plus ib, then converting that a plus ib first into this format of cos of theta plus I sin theta is always recommended. Anyways, now coming back to the main question, because we are already having it in the format of cos of theta plus I sin theta, I can say that my z is equal to r e power of I theta, right? Where theta is the argument of the complex number. And I can expand my e power of I theta as cos theta plus I sin theta. So whenever I'm dealing with my complex number, which is in this format, I can straight away say that the argument is going to become theta. Now, along with that, if I'm dealing with a negative sign in between, what does it indicate? It indicates that I am having e to the power of negative I theta. Because in that case, I'm going to have r times cos of negative theta plus I times sine of negative theta. But I know that cos of negative theta can be written as cos theta and sine of negative theta can be written as minus sine theta. So over here we can see that argument becomes negative theta if I'm dealing with e to the power of negative I theta. Okay, so that is exactly the same thing we are seeing in the denominator. So for the denominator, you are going to have the argument. So I'll just mention these things over here. That argument for cos pi by 7 minus I sine pi by 7. You can see that cos became positive because cos of negative theta is same as writing positive cos theta, but sine became negative. So sine of negative pi by 7 is same as writing minus sine of negative pi by 7. So from this we can say that the argument must be equal to negative of the angle, which is negative pi by 7. So that is for the denominator part. Now what about the numerator part? So argument of um, cos of pi by 7 plus I sine pi by 7, and that is power of 4. Now to solve this, I have given the second expansion over here of z power of n. So z power of n can be written as r power of n and e to the power of I into n theta. So now again r power of n is written as it is, then e power of I n theta can be expressed as this, where now the argument, that is n theta, can be written over here like this. So for this type of equation, I know that the argument of this complex number is always going to be n theta. And now there is a positive sign, so I don't really need to deal with the conversion. So the value will be n theta. N is 4, theta is pi by 7, so it is going to become 4 pi by 7. Okay, a lot of explanation. I'm sure it's going to be a bit boring for the people who are already aware about the concept. But yeah, this is for the people who are new to this kind of concept. But anyways, that is how you get this done. And then finally, you can say that argument of u will be equal to this argument minus this argument, which is 4 pi by 7 minus of minus pi by 7. And let's see what are we ending up with. So 4 pi by 7, then minus of minus pi by 7. Obviously, if I do it manually, it's going to be 5 pi by 7, but yeah, just in case if you're not sure, then you can always use your calc. 5 pi by 7 will be your final answer for your first part. Now, in the second part, we are given that the complex number u and u star are plotted on the Argand diagram. So u star is nothing but the complex conjugate of u, right? So let's say, for example, if I'm having a plus ib as u, then a minus ib will be its conjugate, right? It's complex conjugate. So if I have to plot this on the Argand diagram, describe the single geometrical transformation that maps u onto u star and state the exact value of u star, or I should say argument of u star. Okay. So for this, what I can do is I can simply plot this kind of thing over here and just give you an overall idea of how it's going to be like. Okay. So this is my plane where I plot real values on the x-axis and the imaginary values on the y-axis. So let's say a plus bi is somewhere over here. Okay, this is your a plus bi. This is your a and this is your b. Similarly, if this is your u, then u star will be over here because it is given by a minus bi. Right. So this is, let's say, a plus bi. This will be a minus bi. So if you can describe the single geometrical transformation to go from this u to u star, what it will be? It is simply the reflection with respect to your x-axis or the real axis. So you can mention that u star can be obtained by taking reflection of u with respect to real or x axis. And then you're also asked to state the exact value of argument of u star. So let's say for the u, if this is the argument, let's say theta. So obviously it is moving the same angle over here, but now in the negative direction. So this will be negative theta. So because we have got the argument of u as 5 pi by 7, the argument of its complex conjugate will be the negative of that. So I can also state that argument of my u star will be negative 5 by 7. So there are two different answers that we had to give for this part B. The first one is about the reflection. Okay, I'll just mark that up over here. That is your final answer. And the other final answer is about stating the argument of u star. So that is how you solve this question. Now moving on to question 6. Over here we are having a very classical question that we get in logarithms. We are having a graph of ln y and x on the x-axis. Now because we are having a straight line, the question is based on converting the given ay is equal to bx in the format of the straight line, and this straight line for ln y and x is having the coordinate 0.50 for the x, 2.24 for the ln y, and respectively this coordinate as well. Now based on this, we'll be asked to find the values of a and b. So if you read the question, it is going to ask you exactly the same thing, where we have to find the values of a and b correct to one significant figure. So the concept that I've written over here is to convert the ay is equal to b power of x in the format of the straight line equation, that is y equal to mx plus c. But in place of y, you need to get ln y. In place of x, you're going to get x. And then you're going to find this unknowns m and c in terms of the a and b. Okay, this should be in terms of a and b. Okay. And then once you get the actual value of the y-intercept and the gradient of this line using the 2 points given on the line, you can directly equate it with the gradient and the y-intercept that you got in this equation. And that is how you solve this question. Easy 4 marks, okay? So for this, I'm going to say that I'm going to introduce ln on both the sides. So it is going to become ln AB is equals to ln b power of x. Applying the addition formula for the logarithm when there are multiplication sign in the input for the two terms, it's going to become ln a plus ln b. Okay, I guess I've done a small mistake over here. It's not b but y. So yeah, just a small mess up over there. Ay and ln y is equals to, I can use the power rule to bring x down, ln of b, and now I need to keep ln y to the left side, is equals to ln b is going to now be my gradient because it's multiplied with x, and then minus ln a is going to be my y-intercept. So for this equation, I know that this is going to be my gradient, okay, and this minus ln a is going to be my y-intercept. So first of all, let me go ahead and find out the value of the gradient by using both of the points given to us. So in that case, I just have this dashed line, or let me just use a different color so that it's looking good, okay. And now I'm going to use my orange color to say that my m is equal to, the change in y is 8.27 minus 2.24 divided by the change in x 3.40 minus 0.5. So let's see what is it going to give me as the final answer for the gradient. And if I take out my calc, where is my calc? Yeah, there it is. So division of 8.27 minus 2.24 over 3.4 minus 0.5, it gives me 2.07931, 2.07931, 2.07931 dot dot dot. So now that I'm having the value of the gradient, I can simply equate it to ln b to find the value of b correct to one significant figure. And exactly the same thing I can do for the c. So how can I get the y-intercept using these points? It is pretty simple. We know that y is equal to mx plus c. Now let me change another color to get the c. So c will be equal to y minus mx. In place of y, you put, let's say, for example, 8.27. In place of m, you put this value of the gradient that you've just got, 2.07931 dot dot dot. And for the x, you need the respective x coordinate when y is 8.27, that is 3.4. So this is going to give you the value of y-intercept to be, let's see, so 8.27 minus answer times the x value was 3.4, as you can see from here. And if I get the value, it is going to be 1.20034. 1.20034. And then dot dot dot, I'll just see if there is no rounding up. Okay, no, there is no rounding up, so we are good to go. Let me just plug in my laptop charger just a second. Okay, yeah, let's continue now. Now my C is equal to this, so this is equal to minus ln. So how can I get my A? By simply equating with minus ln. And for that, I'm going to go ahead and say that, therefore, my ln B is equal to 2.07931. And this is going to mean that my B will be equal to, I'm taking E as the base for both the sides and I'm raising this as the powers. So E power of ln B is same as writing B, because E power of ln of anything is equal to anything. So in this anything, it is B, so I'm writing B. And is equal to e to the power of 2.07931, which implements that the value of P that I'm going to get over here is e to the power of 2.07931, and it's approximately 8.0 correct to 1 SF. So 8.0 correct to 1 SF. And now I can repeat the same calculations for getting the value of A. And for that, again, I'll use my red color and say that, therefore, my minus ln A is equals to 1.20034, which is going to basically be, I'm going to shift my minus sign to the left hand side, so it's going to become A is equal to e to the power of negative 1.20034, and this will implement that the value of A that I'm going to get over here using my calc will be e to the power of negative 1.200020034. Okay, that is 0.3 correct to 1 SF. So 0.3 will be your final answer for the value of A correct to one significant figure. So yes guys, if you are aware about this type of questions, these are the very classical questions in the logarithms. So yeah, just make sure you're having a good practice about this and you're good to go. And now for the next question, it is given that we have to show that this equation can be expressed in this equation, where we are given that 10x will never be equal to 0. So if you notice, the concept that we need to know over here is, how can I expand my 10 to x and convert it into the 10x term? So I need to know the double angle formula for 10 to x. If you are not remembering it, you can always find this in your formula booklet. And then I'm just going to replace this with this, and then I'm just going to do the algebraic manipulation, not the algebra actually, but the algebraic manipulation to get the common denominator so that I can shift that common denominator to the 0 side. So yeah, let's see how we can get this done. I am having my 10 cube x, so I'll write my 10 cube x as it is. Then I'm having plus 2 times 10 to x. So 2 times 2 10x will be 2 times 2 is 4. So 4 10x divided by 1 minus 10 square x. Then minus 10x is equal to 0. So to get the common denominator of 1 minus 10 square x for here and over here, or else in other words, you can say that I'm multiplying my 1 minus 10 square x on both the sides. So if I'm multiplying my 10 cube x with 1 minus 10 square x, what am I left with? 10 cube x into 1 will be 10 cube x. Then 10 cube x into minus 10 square x will be first of all negative sign. And then 10 square and 10 cube becomes 10 to the power of 5. I am adding the powers. Then if I multiply my 1 minus 10 square term with this term, this denominator is going to be cancelled out with that term that I'm multiplying. So I'm just left with 4 10x. Then if I multiply my minus 10x with the 1 minus 10x square, what am I left with? Minus 10x into 1 is minus 10x. And then minus minus becomes plus. 10 into 10 square is 10 cube. Now taking everything to the right hand side, because I want the main power to be positive, and I can see that everywhere 10 is common, so I can take common factor out. Okay, so I'm going to say that everything to the right hand side first of all is going to become 10 power of 5x. Then this is 2 10 cube x, so on the right hand side it's going to become minus 2 10 cube x. And then 4 10x minus tan x is going to become 3 tan x. So on the right hand side, it's going to become minus 3 tan x. And now take the tan x as the common factor. So you're left with 10 power of 4x minus 2 tan square x minus 3 is equal to 0. And from here we can say that therefore either my tan x is equal to 0 or 10 power of 4x minus 2 tan square x minus 3 is equal to 0. And this is exactly what we are asked to prove in this part. And we know that this cannot happen because tan x is equal to 0 is given to us. So I can say that I'm going to reject this. And then this is how I'm going to prove my answer for the part 1. Now for the second part, it is given that hence solve the equation tan cube 2 theta plus 2 tan 4 theta minus tan 2 theta equal to 0 in the 0 to 180 degrees or 0 to pi radians, giving your answers in the exact form. So the concept over here is the first thing we need to know is we need to relate our equation in part A, this equation, with this equation. And the only difference, if you can notice, this x is now converted to 2 theta. So my x becomes 2 theta. Over here it was 10 2x. So 10 into 4 theta, not into but 10 of 4 theta minus 10x becomes 10 2 theta. So I know that over here my x has become 2 theta. And therefore I need to solve for double angles by relating this equation with the equation that I've got over here. Okay, so it's a hidden quadratic equation in the double angle of 10. And if I have to rewrite this over here, it's going to be something like this. 10 power of 4 of 2 theta. And then I'm having minus 2 tan square minus 2 tan square of 2 theta minus 3 is equal to 0. So as I told you, it's a quadratic or a hidden quadratic equation in terms of tan 2 theta. So we first need to solve for tan 2 theta, then get all the values in between 0 to 2 pi now, because see, this angle was only for theta. So if we first solve for 2 theta, it will be in between 0 to 2 pi. And then we divide all the answers by 2 to get all the values of theta in between 0 to pi. This is a classical thing that we do in the AS level trigonometry. So I hope that you are aware about that. And to solve this, we're going to use ASTC or cast diagram. And therefore, the first thing that I'm going to perform over here is to take my calci and go to my mode phi 3. I'm going to say that my value of hidden quadratic with the highest power is 1. Then the second one is minus 2. And the last one is minus 3. Okay. So my x1 is coming out to be 3. And then x2 is coming out to be minus 1. So my tan square theta is coming out to be minus 1. Or tan square theta is coming out to be 3. I guess it was 3. Let me check. Yes, it was 3. So based on this, I can just have tan square theta plus 1 as a factor and tan square theta minus 3 as a factor, which is equal to 0. So if this is equal to 0, you get tan square theta equal to minus 1. If this is equal to 0, you get this is equal to 3. Now based on this, okay, I guess I just forgot one thing. It's not theta, it is 2 theta, right? So I'll just quickly get rid of the theta and write it 2 theta over there. So let me going very quickly. So tan squared 2 theta, tan squared 2 theta, tan squared 2 theta, and tan squared 2 theta. So from here we get that my tan 2 theta is going to become square root of negative is not possible, right? So this value is just going to be rejected. And from here I can say that, let me first say that this is rejected. And from here we are going to say that my tan 2 theta will be either square root of negative square root of 3 or tan 2 theta is positive square root of 3, right? So based on this, now I can use my cast diagram to proceed forward. So I'll use, let's say, another color. For tan 2 theta is equals to positive root 3. Because we are dealing with 2 theta now, I'm going to solve this in between 0 to 2 pi. Because I'm dealing with 2 theta now, not just the theta. The theta was in between 0 to pi. Where is it? Where is it? Yeah. And now I'm changing this theta to 2 theta first. and therefore I'm going to get this. And then according to my ASTC diagram, where is 10 positive? It's positive in the first quadrant and in the third quadrant. So my final solution is going to be becoming, this is the value of theta and this is pi plus theta. Okay, so what is this theta? I just call this theta basic, and theta basic is always the tan inverse of the positive value written over here. Even if it was negative, I can take positive as well. So I can say that over here my theta basic will always be tan inverse of modulus of whatever is written over here, and modulus of root 3 is root 3 itself. So tan inverse of root 3 is theta basic. So from here I get that 2 theta is equals to my theta basic and pi plus theta basic. Okay, and I can now say, I'll just convert this to theta. So my theta will be equal to theta basic by 2 and pi plus theta basic by 2. I'm going to plug in the values in the CAIE in a while. But along with that, I'm also going to solve for tan to theta. I'll just use a different color because this is a bit lighter shade. So yeah, now for tan to theta to be negative root 3. Again now 0 to 2 theta is what I'm looking forward to because of the double angle. And then now I need to look forward to where I am having tan negative. It is negative in the second and the fourth quadrant. So we know that this is theta basic. So this is going to become, I'll use red color to mark the final answers. So this is pi minus theta basic, and this is 2 pi minus theta basic. Okay. So right away I can go ahead and say that my final values of 2 theta is going to become pi minus theta basic and 2 pi minus theta basic, and therefore my theta will be equal to pi minus theta basic by 2 and 2 pi minus theta basic by 2. See, this is just to explain you everything in raw format. If I have to do it in the examination, I'll be doing it right away in the CAIE and write my final answers. Okay, but yeah, now I can say that over here I'm getting the values of theta. I'll just use my red color now and say that this implements that my theta over here will be, if I take out my CAIE, mode 1, and I need to use my mode as radian, so I'm going to convert it into radian modes. So I know that this is theta basic is what, tan inverse of root 3, right? Okay, so my first solution will be pi minus my theta basic. Oops, let me go back. Pi minus theta basic over 2, and it's going to give me pi by 3. So pi by 3 is one of the solution that I'm getting, and the other solution will be 2 pi minus 2 pi minus tan inverse of root 3 over 2, which comes out to be 5 pi by 6. So I got two solutions of theta by taking my tan theta as negative root 3. I'll have two solutions over here as well. So let me write that over here quickly. So this will implement that my theta is tan inverse of root 3 by 2. So tan inverse of root 3, whatever is the answer, I'm going to divide that by 2. So I'm left with pi by 6. And the other answer will be pi plus tan inverse of root 3 divided by 2, that is going to give me 2 pi by 3. So in total we are having 4 different values of theta in between 0 to pi. So this is again now in between 0 to pi, because now we are not dealing with 2 theta but just the theta, and even over here this is in between the given domain of theta. Okay, I guess I wrote 2 pi, it is just pi. Okay, in between 0 to pi is what I'm looking forward to. And basically this is how you solve this question. And I hope that this was time consuming over here for you if you are new to this. But if you practice this, then this is not going to take more than 2 minutes of time for you to solve this entirely. If I'm just talking about part B. Now for question 8, in part A, We are given the parametric equations for the curve x is equal to tan square 2t and y is equal to cos 2t. And then the value of t is lying in between 0 to pi by 4. And we are asked to show that dy dx is equal to minus half cos cube 2t. And again, if you are someone who is aware about parametric equation, then we can just get the derivative with respect to t, that is dx dt and dy dt. It's just the short form of writing dy dt and dx dt, that is y dot x dot. If t is with respect to time, this is the short form of writing this. And dy dx, the short form is y dash. So my y dash, that is my dy dx, is written as dy dt over dx dt. Okay, so that dt dt, if I'm considering t as time, then I can write it as y dot over x dot. But anyways, now based on dy dt and dx dt, using the basic trigonometric manipulations, I will be able to get the dy dx. And therefore I can say that my first of all dy dt, I'll not say therefore, I'll just write arrow. So my dy dt is what? Obviously, apart from this, you need to also know about the um, differentiation of, uh, let me write it in a proper way, that if it is any trig term, trig to the power of n with n theta, which means there is multiple angle, it is also having some power, and you also need to know the basic of differentiation of trig with multiple angle, so that is with n theta itself. So yeah, that is the differentiation of this thing. So if I talk about this, the differentiation of cos 2t will be minus sine 2t. And then because we're also having 2t over here, so with respect to the chain rule that we've learned in ES level, this will be multiplied with 2. So answer will be minus 2 sine 2t. And then if I have to find my dx dt, so first I apply the power rule to bring the power down. So it becomes 2 10 to the power of 1 because I'm reducing my power by 1. That is the power rule of differentiation. And now I'm having two functions, 10 and as well as the input of the 10, that is 2t. So the differentiation of 10 is going to become sec square. So sec square 2t. And then the differentiation of 2t is what? 2. So my final answer over here is 2 times 2 is 4. So 4 sec square 2t multiplied with 10 2t. And now this implements to find my dy dx. I need to have my dy dt over dx dt, which is minus 2 sine 2t. And then I'm just going to convert my sec into cos and 10 into cos as well, sine and cos as well. So 4 sec squared 2t can be written as what? This is same as writing 4 over cos square 2t. And this is same as writing sine 2t over cos 2t. And we have to bring cos cube 2t and we need to get rid of sine 2t term, right? So let's see how we're going to deal with that. So my dy dt is written as minus 2 sine 2t. And for dx dt, I'm going to have 4 sine 2t over here, which is divided by, okay, we are having the main division and then we are having a division over here, that is cos cube 2t. And now this cos cube 2t is directly going to go in the numerator part. Okay, it's the fraction a by b over c. So c goes on the top to become ca over b. So following this rule of the algebraic manipulations, along with the trigonometric manipulations, what am I going to get? The first thing that you notice over here is that this sine 2t and sine 2t gets rid of. This 2 ones are 2, 2 2s are 4. So I'm left with what? The final thing that is required in the question. That is, therefore, my dy dx will come out to be minus half. Then cos cube 2t goes on the top. So minus half cos cube 2t is what I get. And as you can see that this is exactly what I had to prove. So the best way of solving this kind of questions where you're dealing with trigonometric things and you have to prove something, always make sure that whatever kind of process you use to prove something, you're always trying to check whatever is the current format, how can I go ahead one step closer towards the given format. Okay. So in my case, see over here 4 sec square 2t and 10 2t was there. And in the final expression, I cannot see anything in terms of sec and tan. So I thought to convert it into the sine and cos so that after doing some of the trigonometric manipulations, I'll be left with cos cube 2t tan along with the minus half. That is how I solved the first part. Now for the second part, we are asked to find the equation of the normal to the curve at the point where t is equal to pi by 8. Okay, so I'll just need to write one more concept over here, that m of perpendicular equation is same as writing minus 1 by m of the perpendicular to that m. So yeah, based on that, I can solve this part B as well. Okay, because now first of all, I'll need to find my x value when the value of t is pi by 8. So x was 10 square 2t. So 10 square 2 into pi by 8 will be pi by 4, and pi by 4 is 1. So 10 square of pi by 4 will become 1 square, which is equal to 1. And then y is equal to, it was I guess what, cos 2t? Yes, cos 2t. So cos of pi by 4. So cos 45 is root 2 by 2, if I'm not wrong. I'll just cross check it. So yeah, cos of pi by 4 is coming out to be root 2 by 2. Great. Alright, so now that I'm having the x and y coordinate, I also know the value of my gradient. Okay, I don't know the value of the gradient. I need to find it by substituting the value of t over here as pi by 8. So I can say that the value of m of perpendicular or the normal is equals to negative 1 by m, which is equals to negative 1 by negative half cos cube 2t, which is pi by 4. Okay, so negative, I'll just directly solve this in calculus so that I'm not having any room of errors. So negative 1 divided by negative half can be written as negative 0.5, and then I'm having cos of pi by 4, and then I'm having cube to this, and cube is just for the cos term. So if I solve this, I'm getting 4 root 2. So 4 root 2 is the gradient for the normal line, and therefore equation of normal will become equation of normal. Okay, I'll just not write this 1 2 3. It's not a good way of writing the solutions. I'll just have my arrow to denote these things. Okay, x y. Okay, I'll use blue color. X y gradient. And now the equation of normal will be in the format of y is equals to mx plus c, or m perpendicular x plus c. Now we know that the value of y is root 2 by 2. The value of m is 4 root 2. The value of x is 1. What will be the value of c? So my c comes out to be root 2 by 2, and then minus 4 root 2, and it's going to be simplified as minus 7 root 2 by 2. And therefore my final answer will become y is equals to 4 root 2x minus 7 root 2 by 2. I hope that the form that I've written is correct as we want in the question. Yes, it is correct. And that is how you solve this question on the parametric equations, where you also had to find the equation of the normal when t was equal to pi by 8. Now for question 9, with respect to the origin, points A, B and C are having the position vectors as given to you over here. The point is such that ABCD is a trapezium with DC is equal to 3AB equation that is given to us. And based on this, we are asked to find out the value of the OD, that is the position vector for D. So straight away, I don't really think about this kind of questions much. I just express my DC in format of their position vectors, that is going to be OC minus OD, and AB will be OB minus OA, that is multiplied with 3, and that is the equation that I'm going to get. And then I'm just going to make OD the subject from here. So I'm going to get that OD will be equal to OC minus 3 times OB minus OA. Simple as that. And then if I solve this, my OD will be equal to, so OC is minus 3 times minus 3, then minus 3 times OB minus OA, which is 0 minus 2. Then for the y coordinate, I'm going to have my OC as my negative 2. Then negative 3 into OB minus OA, which is 4 minus 1, which is 3. And then 2 minus 3 times 1 minus minus 3, which is 4. And from here, I'm going to get that therefore my OD comes out to be, so the first one is what? Minus is going to be positive, so positive 6 minus 3 is 3. Then minus 9 minus 2 is minus 11, right? 3 3s are 9, 10, 11, okay. 3 4s are 12, minus 12 plus 2 is minus 10. So this is the value of OD that we have got, or I should say the OD vector that we have got. Now in part D, the diagonals of the trapezium intersects at point P, as we can see in the diagram. I've just drawn a very normal trapezium and I've drawn the diagonals where it is going to intersect at point P. Now get the vector equations for the line of AC and BP. And once I'm having the vector equations of the line, I can equate them to get the x, y, and z coordinates and then find the point of intersection by solving this line. And this is again, the concept over here is just to find the point of intersection given two lines of vectors for the lines. So first of all, you need to find the vector equation of the line. So my first thing that I need to do over here would be, what is the vector equation for the line AC? So I just need either of the point AO or OA or OC. I'll use the one that is easier for me to carry forward with. So 2 1 minus 3 is what I'm going to take. 2 1 negative 3 plus lambda times the AC vector. So what is my AC vector? AC will be the direction vector, right? So based on that direction, I can see that AC is OC minus OA. So minus 3 minus 2 is minus 5. Then we have minus 3 and then we have 5. So minus 5, minus 3 and 5. That is how we get the vector equation of AC, where this is the point lying on the AC and this is the direction vector of that AC. Similarly, I can also find vector equation for BD, and out of BD, which is the easier point for me for the calculation, O. And D, what is D? 3 minus 11 and 10. Okay, so 0 4 1 is the point on the line, 0 4 1 plus mu, which is a scaling factor, in the direction of BD. Now what is BD? It is OD minus OB. So 3 minus 0 is 3. So I'm just going to write 3 over here. Then minus 11 minus 4 is minus 15. And then I'm left with minus 10 minus 1 is minus 11. Right? OD minus OB minus 1 is minus 11. So now that I'm having two equations, I can now equate their x coordinates, y coordinates, and z coordinates. Okay, I just need any two of them, and the third one is just the z coordinate, which I need to find as the point of intersection. So if you have ever solved the point of intersection for the two vector equations or the line of the vector equations, then this must be very easier for you to digest. If not, just note that the concept we are using is how we can solve the point of intersection between the two lines. So 2 plus lambda into minus 5 is, see, first of all, see, I know that the equation of line is this is equal to r and even this is equal to r. Okay, so I'll just write it in blue. Okay, so this is equal to r, which is nothing but a point lying on the line, and this is also equal to x y z. And because both of these lines are intersecting at point B, so this x y and z and this x y and z must be equal to each other. And that is why I'm going to equate my x coordinate of AC with BD, then y coordinate of AC with the respective y coordinate of BD, and so on and so forth for the z coordinate. And that is how I'm going to get over here. For the x coordinate, if I see, it will be 2 minus 5 lambda, that is equal to 0 plus 3 mu, that is 3 mu. Then I'm having 1 minus 3 lambda equal to 4 minus 15 mu. And lastly, I'm having minus 3 plus 5 lambda is equal to 1 minus 11 mu. Now I can just use any of the two equations to solve for lambda and mu, and then I'm going to substitute my lambda to get the values of the p, or maybe mu to get the values of the p. In both the cases, because this is the same point of intersection, we are going to get the same value. So now what I'm going to do is I'm going to, let's say for example, say that this is my equation. Okay, so I guess this is a bit complicated to solve directly. So no problem, I'll just say that this is same as writing 3 mu plus 5 lambda is equal to 2. This is same as writing 15 mu minus 3 lambda is equals to 4 minus 1 is 3, and this can be written as 11 mu plus 5 lambda, and this is equals to 1 plus 3 will be 4, right? So in both the cases we are having 5 lambda, if you can see. Okay, and based on that, now what I can do is I can simply go ahead and, let's say this is equation 1 and this is equation 2. I can say that I want to do 1 minus 2, so I'll be left with 3 mu minus 11 mu, as it's going to become minus 7 mu. Then lambda is going to be cancelled out. 2 minus 4 is what? Minus 2. So from here you directly got the value of mu as what? 2 by 7. Now you don't need to find lambda. You can directly substitute the value of mu as 2 by 7 over here to get the x, y, and z coordinate. And just if you want to compare your answer if it's correct or not, you can go ahead and just get the value of lambda, put the value of lambda over here and see if it's equal to what you got for mu. If it is equal, then you are 100% sure your answer is correct. Okay, but if you trust your process, if you are very confident with your algebra and this solving this kind of equations, then you don't even need to compare it, because yeah, you are very confident about yourself. Therefore P point is going to have the x coordinates, or I can say this as OP will be equal to, so P is the point on the intersecting part of A, C and BD, and with respect to origin I can say that the position vector of P will be equal to what? So 3 mu. So 3 mu is what? 3 into 2 is 6, so it's going to be 6 by 7. Then 4 minus 15 into 2 by 7, I'll use my calci for that. So, oops, where is my calci? Yeah, okay. 4 minus 15 into 2 by 7, and this gives me minus 2 by 7, and then 1 minus 11 mu. 1 minus 11 into 2 by 7 is going to give me minus 15 by 7. So that is how you're going to get the position vector of P, that is OP. Now for the next part, using the scalar product, we have to calculate the angle ABC. Okay, so from the trapezium, I've taken this particular part, and this is the angle that I'm looking forward to. So now I need to have two vectors, that is AB vector and the BC vector. And if I'm having these two vectors, okay, or I should say the directions in AB and BC, if I'm having these directional vectors, then I'm going to use this cos theta is equal to the scalar product of AB and BC and divide that with the magnitude of AB vector and the magnitude of BC vector. And from here I can get the value of that theta. Okay, I'm going to assume it's going to be a what do you call this, acute angle. If in question it was specifically asking about the obtuse angle, you can do 180 minus acute to get the obtuse, but over here not anything is not really mentioned, so I'll just stick with the scalar thing, and yeah, we can use this formula to get it done. So for this, the first thing I'll need to do is to get the AB vector and BC vector. So my AB vector will be what? It will be OB minus OA. So OB minus OA, so minus 2, then 3, minus 2, 3 and 4, minus 2, 3 and 4. Then similarly, the BC vector will be OC minus OB. So minus 3, then minus 6 and 1, minus 3, minus 6, 1, minus 3, minus 6 and 1. Now, if I take the scalar product of A, B and B, C, what do I get? So minus 2 into minus 3 is positive 6, minus 6 into 3 is negative 18, then 4 into 1 is 4. So if I solve this in CAIE, I need to have the absolute value of this. Okay. So 6 minus 18 plus 4 comes out to be negative 8, but because of the modulus sign, it's going to become positive 8. And just like this, what is the magnitude of AB multiplied with magnitude of BC vector? So it is going to be equal to square root of minus 2 square plus 3 square plus 4 square multiplied with square root of minus 3 square plus minus 6 square plus 1 square. And then if I just plug this directly into my CAIE, let's see what do I ending up with. Okay, so minus 2 square is just writing 4 plus 3 square is 9 plus 4 square is 16, and this again multiplied with the square root of 3 square is 9, 6 square is 36 and 1, so it's coming out to be 36.5239, 36.5240, 5240, let's say. Okay, 36.5240. Okay, great. Now this implies, or therefore theta will be equal to my cos inverse of 8 over 36.5240, and this helps me get the value of theta as, now I need to be in my degrees mode, so shift mode, degrees, and now cos inverse of division of 8 by 36.5240, and this comes out to be around 77.3 degrees correct to 1 decimal place. 77.3 degrees correct to 1 dp. And that is how you solve the entire question on the vectors for this paper. The important thing that you need to keep in mind is that first of all, if this kind of relationships are given to you, you convert everything into position vectors. Then for this kind of part, if you are able to draw the diagram, then coming up with the ideas becomes pretty simple. And then for this part, for the scalar product, to calculate any angle, there is only one formula that we know about. And yeah, that is how you can go about solving this entire question. And now for question 10, it is given that a balloon in the shape of sphere has a volume V and radius R. Now air is pumped into the balloon at a constant rate of 40 pi. So dV dt is given to us over here, okay? dV dt, that 40 pi is going to be started when t is 0 and r is equal to 0. These are the initial conditions that is given to us. And dV dt is equal to basically 40 pi. Now at the same time, they are mentioning that air begins to flow out of the balloon at a rate of 0.8 pi r. So this was the input, and then the output, that is basically you are getting out, the air is coming out with the volume of 0.8 pi r. And the ball remains a sphere at all the times. So because it is sphere at all the times, I know that there is an equation of V is equals to 4 by 3 pi r cube as the equation of the volume of the sphere. I can use this to get my dV dr. Okay, and I also have the equation of my dV dt over here, that this is the inflow, this is the outflow of the volume, and based on this I can prepare this differential equation in terms of dr dt. Okay, so again these type of questions are pretty much straightforward that we have. So to get dr dt, I need to have dr dv, which I can find from the equation of the volume of the sphere, and I'll need to multiply this with dV dt, which I've just got on the top. So based on this, I'll say that my dV dr will be equal to 3 and 3 gets out, so 4 pi r square is what I'm having. So this is my 4 pi r square, but that is dV dr, so I'll need to do 1 by 4 pi r square for dr dV, and this is multiplied with 4 pi, or I should say 40 pi minus 0.8 pi r. Okay, now based on this, I just need to simplify my equation to get what we have over here. So I can just go ahead and say that dr dt, where I can take pi as a common factor, and along with that I can maybe take 0.8 as a common factor as well, because for the r we don't have any 0.8. So I'll just take 0.8 pi as a common factor from the top. Okay. So what is 40 by 0.8? Let me check. 40 by 0.8 is going to be 50. So now I'm having 50 over here minus r divided by 4 pi r square. So 4 pi r square. Now this is going to be therefore equal to dr dt is equal to what is 0.8 by 4. So 0.8 by 4 will come out to be 1 by 5. So I'm left with, see, this pi and this pi gets cancelled out. So I'm left with 50 minus r over 0.8 by 4 was 1 by 5. So 1 on the top, 5 on the bottom, and r square. And this is exactly what we have to prove. 50 minus r over 5r square. So how did I go about this question? The first thing was, in order to get the equation or the differential equation for dr dt, what are the things that are given to me? So the inflow and outflow rate was given to me. Inflow was 40 pi, outflow was 0.8 pi r. So from there I got dv dt. And I know that the other constant is r. So I need to have an equation with respect to volume and r because volume is also involved. And because they've mentioned that the ball remains a sphere all the time, so I can use the equation of the volume of the sphere to get my dv dr. And then to get dr dv from dv dr, I'm just doing the reciprocal of that, and this is what I get. Okay. Now for part B, it is asking us to find the quotient and the remainder when 5r square is divided by 50 minus r. So we are having 5r square, which we have to divide by 50 minus r. So I'll need to find the quotient and the remainder. Okay. So what do I need to multiply my 50 with? Okay, to get 5r square. So I basically need to multiply this with r by 10, right? So r by 10, if I multiply with 50, I'll be getting 5r square. So 5r square, and then, okay, wait, what am I doing? Am I dumb or something? Yes, I am dumb for sure. So I'll need to think about what do I need to multiply my r with to get my 5r square. So that is going to become negative 5r. Yeah, this makes sense. Yeah, great. So this negative negative becomes positive. R and r is r square, and then minus 5 into 50. 5 5s are 25. So minus 250 r. Obviously there is 0 over here. Then if I do the subtraction, I'm left with, this gets cancelled out. I'm left with 250 r. And then what should I multiply my r with to get 250 over here? So 250 r. That is going to become negative 250. So that negative 250 into negative r becomes positive 250 r. So I'm going to subtract my 250 r. And then what is minus 250 into 50? Let me check. Minus 250 into 50. That is going to be 12500 with a negative sign. So from here we can clearly see that this gets cancelled out and I'm left with 12500. Okay, I hope it was 12500. Yes, indeed it is. And therefore what I can say over here is that my quotient will be minus 5r minus 250, and my remainder is going to become 12500. And guess what this is? Yes, you guessed it right, my dear friend. It is going to be your final answer to this part. Okay. Now for part C, it is saying that we have to solve the differential equation in part A and obtain the expression for t in terms of r. So dr dt was given to you as, if I'm remembering it correctly, 50 minus r over 5r squared. Let me cross check it. Yes, 50 minus r over 5r squared. So based on this, if I can relate it with the previous part, if I'm doing 50 minus r and if I'm dividing that with 5r squared, I'm going to have the quotient as minus 5r minus 250 and the remainder as 12500. So it basically indicates that I can write my 5r square as 50 minus r into minus 5r minus 250 minus 5r minus 250 plus the remainder 12500. So from the concept of the long division, I am just rearranging my 5r square, okay, which 5r square? This 5r square, in terms of the divisor into the quotient plus the remainder. So that is what I'm going to get, okay. And now just I had this idea of like, relating my second part in the third part. Now let's see how can I use it in this particular equation. So the concept over here is to first separate the variables where I'll have t on the left hand side and r on the right hand side, or the vice versa is also fine. It's just that I want to make t the subject of formula so that I can just flip the equation. So in this case you will see that r is on the left, t is on the right, but then I can just flip the equation to make t the subject, okay. So yeah, that was the first point. Then I need to integrate on both the sides. uh, t will be integrated with respect to dt, r will be integrated with respect to dr. Then we just need to have a quick algebraic manipulation to find the final expression of t in terms of r. So for that, let me just go ahead and separate this, and it's going to become 5r square divided by 50 minus r is equal, oh sorry, dr is equals to 1 dt, right? There is nothing on the right hand side, there is 1, so 1 into dt, okay. Going to integrate on both the sides and then just going to make t the subject, and that is why I was saying keep t on the left side, this on the right hand side. So even either way is fine, right? There is no as such rule. So I just make sure I am deleting this because this is just going to create some confusion, because either way it is just the same thing. Alright, now after this over here I can say that if I'm dividing my 5r square with 50 minus r, I am left with this thing. So I'm going to replace my 5r square with this, and what am I going to left with? Let me show it to you. Okay, therefore 5r square is 50 minus r times minus 5r minus 250 plus 12500, and this is divided by 50 minus r, and this is equals to dt. How much amount of space is left? Let me check. Oh, there is only small space left. Okay, no problem. So this can be written as this and this gets out. I'm left with what? Minus 5. Oh, there is also dt, dr over here. Okay. So minus 5r minus 250. Why am I left with this? Because 50 minus r is going to be cut over here. And then I'm also having 50 minus r over this term. So it is going to be plus 12500 over 50 minus r. And this is all multiplied with dr, so I can directly differentiate this, or I should say integrate this with respect to r, and on the right hand side it is pretty simple. Integration of dt or 1 dt is simply t. So this is going to give me what, so first I'll need to integrate this. It's going to become 5 by 2 r square, then minus 250 r, then this is plus ln of 50 minus r multiplied with negative 1, and then we also have 12500 is equals to t plus c. I am having the integration constant for both the sides combined on one side, on the right hand side, okay. And from here I can just say that when the value of t was 0 and r was 0, what is the value of c? Because I know that initially t and r both were 0. So in that case I'm going to left with, when t is equals to r is equal to 0, you are going to get, this is 0, this is 0, you are left with ln 50, right? But they're also having minus, so minus 12500 ln of 50 is equal to c. And this shows that the final expression of t is going to be, so this is what, negative, or yeah, everything over here is seeming to be negative except this term. So I'm going to write 12500 ln 50. Okay, I'm shifting my c to the left hand side. Okay, so that is why this negative becomes positive now. And then all of the other terms, so 12500 ln 50, then minus 12500 ln of 50 minus r, and then minus 250 r minus 5 by 2 r square. So that is the final expression. I know it's pretty crazy, but yeah, that is what we have ended up with. I hope there are no errors over here. In case there are errors, I'll just have an edit and show it to you over here. And now the part D is pretty straightforward, okay? I'm just going to put the value of R as 12 and get the value of T directly from my CAIE. And that is going to give me, I'm going to open my CAIE and get the answers very quickly. So 12500 ln50, I'm so sorry for my bad accent, guys. Minus 12500 a00 ln of 50 minus r is 12, and then whatever answer we have got over here, we have to do minus 250 into 12, and then I cannot see what is there behind this. It is minus 5 by 2 r square. Okay, so answer minus 5 by 2 into 12 square, which is 144, and this gives me the value as 70.5 correct to 3 significant figures. 70.5 will be the final answer. Okay, we have just simply substituted the value of r. Okay, substitute, or I'll just write it as a concept over here. That is, substitute r in previous part to find t, and voila, that's it. That is how you solve this entire question on differential equation. Now for the last question, we are having f of x is equal to 2 e power of 2x divided by this particular term. We have to find in part A the f dash x, basically the derivative of this function, and then find the exact coordinates of stationary points. So basically when the derivative is equal to 0, I just need to find out the x and y coordinate, and that is exactly what I've mentioned in the concept over here. Now let's get very started about this. The first thing you need to know is about the quotient rule because of the division of this. And the quotient rule says that if I want to divide u and v and then want to differentiate that, it is going to be u dash v minus v dash u over v square, where u dash is nothing but the differentiation of the first part, v dash is the differentiation of the second part, or I should say the denominator. So based on this, I can say that my f dash x will be equal to, my u dash will be 2 times 2 is 4, e to the power of 2x. E to the power of 2x stays as it is, but then because of the chain rule, the derivative of 2x, that is 2, is going to be multiplied with this 2. And then this is multiplied with the v part as it is, e power of 2x minus 3 e power of x plus 2. Then we are having a negative sign in between from the formula. Then the derivative of this term is going to become 2 e power of 2x, then minus 3 e power of x. Note that e power of x differentiation will never change. The answer will be same as it is. And the differentiation of 2 is 0. This is going to be multiplied with 2 times e power of 2x. Okay. And everything is now divided with, okay, everything is now divided with the square of the denominator, that is e power of 2x minus 3 e power of x plus 2 is equal to, yeah, that's it. And that is your differentiation. Now because we are trying to find the coordinates of the stationary point, we note that dy dx must be equal to 0. And this is implementing what? This is implementing, for example, over here I can take 2 e to the power of 2x as a common factor. I should say 2 e power of 2x as a common factor. And then I'm left with 2 times e power of 2x minus 2 times minus 3 is minus 6 e power of x, and then 2 times 2 is 4, right? And minus 2 e power of 2x, minus minus becomes plus 3 e power of x, and this is equal to 0. Because obviously this denominator, if this is equal to 0, this goes to the right hand side and it becomes 0 itself. And from here I can say that therefore 2 e power of 2x can be equal to 0, or, oh wait, oh yeah, yes, correct. Or this term, if I simplify this and this gets eliminated, I'm left with minus 3 e power of x is equals to negative 4. So from here we can say that we are going to reject this, because to get the value of x I need to bring ln on both the sides, and ln of 0 does not exist. So we're going to reject this solution. And over here I'm left with e power of x is equals to 4 by 3, and therefore x is equals to ln of 4 by 3. So I've simply tried to solve this equation as bringing ln on both the sides, so I can bring x down, and the value of ln is 1. So x into 1 is equal to ln of 4 by 3. So that is how I get the x coordinate over here. Now how do I get the y coordinate? To get the y coordinate, I simply need to substitute the value of x as ln of 4 by 3 in this equation. And for this, what I can do is, now my y will be equal to e power of 2 e power of 2x divided by e power of 2x minus, just a second, e power of 2x minus 3 e power of x. What am I doing? Wait, something is messed up. What is this? So minus 3 e power of x plus 2. Okay. So that was the main question. In place of x, I need to have ln 4 by 3 substituted. And now based on this, let's see what am I getting. So 2 times e to the power of 2 ln 4 by 3, okay, divided by e to the power of 2 ln 4 by 3 minus 3 e to the power of ln 4 by 3 plus 2. So if I have to solve this, I can say that this is same as writing e to the power of ln of 4 by 3 square, that is 16 by 9. And e power of ln of anything is equal to anything. So I'm left with 2 into 4 square is 16, 3 square is 9, divided by the same thing over here. I'm left with 16 by 9 minus e power of ln of anything is anything. So minus 3 times 4 by 3 plus 2. And then if I try to solve this, let's see what am I going to get. Let me take my calci and get this going. So 2 into, what was it? Let me check. 2 into 16 by 9. And whatever is the answer, I'm going to divide it with 16 by 9. Then minus 3 into 4 by 3 is just minus 4 plus 2. So minus 4 plus 2 is minus 2. So minus 16 is what I'm getting. So what does this indicate? This indicates that the stationary point is at ln of 4 by 3, comma, negative 16. And that becomes your answer to the first part of this question. And now let's move on to the next part. Over here, I did not write anything in the concept because it depends on what kind of solution that I've obtained over here. Based on that, I can come up with this whole idea. Okay, so the f of x over here. Okay, so to be honest, it does not really matter. I could have written the concept over here, but I'll do it right up in front of you. The first thing you need to do is you need to know about integration by substitution method. Okay, you should be very much good with the integration by substitution, where you need to convert all the x into u's, including the bounds of the integration, and then based on that we need to get something done. Okay, and if I can see over here, I am having my f of x as 2 e power of 2x divided by this, and I need to convert this first in terms of u. I need to integrate that part and then get my answer as asked in the question. Okay, giving your answer in the format of ln a, where a is a rational number in its simplest form if we apply the bounds to the integration from ln 3 to ln 5. So apply the bounds and use log rules to get answer in ln a format. Okay, so let me have my f of x written over here first of all, that is 2 e power of 2x divided by e power of 2x minus 3 e power of x plus 2. Let me check if it's correct. I am just writing it based on my memory. So 2 e power of 2x and e power of 2x minus 3 power of x. Yeah, it's correct. Okay, guys. So first, let me convert this in the format of u, right? So I know that because I'm assuming my u is equal to e power of x, I'll say that my du is equal to e power of x dx, right? Or du dx is equal to e power of x, and just making du is equal to e power of x dx, and then I can say that my dx is equal to e power of negative x, or basically 1 by u du, right? Because e power of x is u, right? So 1 by e power of x into du will be 1 by u d. Okay. So I've converted my dx in format of u, and now I need to convert this whole equation in format of u so that I can integrate in terms of u. All right. And even if I talk about the bounds, I can convert my bounds as well. So first of all, this is my conversion of u to, sorry, x to u, and then I'll talk about the bounds as well over here. So let me write with some different color now. So when the value of x was ln 5, my value of u will be, so when x was ln 5, my u is coming out to be e to the power of ln 5, which is 5. And then when my x was equal to ln 3, obviously my u will be equal to 3. So that is how I'm going to plan this, and I'm just going to erase this bottom part because it is consuming a lot of extra space. Okay, guys, and now I'm just going to close this up very cutely with my orange pen, and that's it, I'm done. Now let me convert this f of x in terms of u, and it is going to be is equal to, my e power of x is u, so this becomes 2u square divided by, this is my u square minus 3u plus 2, and yeah, that's it. This is, I have converted it in format of u. Now therefore, if I want to integrate my f of x dx from ln 3 to ln 5 in terms of u, it is going to become integration from 3 to 5 of 2u square divided by u square minus 3u plus 2 into dx, but dx is now 1 by u, so into 1 by u du, and this u gets cancelled out, and I'm left with what, guys? I'm left with integration of 2u divided by u square minus 3u plus 2 du. Okay, and yeah, let's see if I can use f dash x over f of x rule. So if I do the differentiation of u square minus 3u plus 2, I'll be left with 2u minus 3, right? I'll be left with 2u minus 3 and not just with 2u. So in a way, I cannot use f dash x over f of x rule over here. So the only thing that I can do over here is to convert this equation into the partial fraction. And for that, what I'll do is I'll take out my calc and see that if I am getting this quadratic equation in its linear factor format. So mod 5, 3, 1, minus 3, and 2 is what I need to plug in. And I'm getting that u minus 2 and u minus 1 are the factors. So I'll bring 2 out, u over u minus 1, u minus 2 du. And obviously it is going from 3 to 5. Okay. And now if I solve the partial fractions along the way, okay, and I'm going to use another color for that. I'm not really able to find a good color. Okay, I'll do with green. I'll just check how many space is given to us. Okay, we are having good space. So now I know that I can write this as u divided by u minus 1, u plus u minus 2, and this is equivalent to saying a by u minus 1 plus b by u minus 2. Do I need to have plus c? No, this is a proper equation or the proper fraction. I don't need to do that. So now I can say that my u can be compared with a into u minus 2 plus b into u minus 1. Now when let u is equals to 2, So in that case, this term goes to 0. I'm left with 0 is equals to b. Sorry, use 2. This term goes to 0. So I'm left with 2 minus 1. So b is equal to 2 is what I get over here. And from that, I can also say that let u is equal to 1. So my 1 will be equal to, this term goes to 0. 1 minus 2 is minus 1. So I'm left with minus a. So therefore, I know that my a is equals to negative 1. B is equals to 2. And then now if I carry forward this part on the left hand side, let me just draw this kind of a box over here to just let know that this is the kind of thing that I've done to get my next step after this. And it is going to become equal to 2 times integration from 3 to 5 for 2 divided by u minus 2 minus 1 divided by u minus 1, and I guess that's it. That is with respect to du. And now I'm going to get 2 times, it will be 2 times ln of u minus 2, differentiation of u is 1 only, then minus ln of u minus 1, and now apply the bounds from 3 to 5. So you're left with what? 2 times 2 ln 5 minus 2 is 3 minus ln 5 minus 1 is 4, then minus 2 ln 3 minus 2 is 1. So I'll just write it as 2 ln 1 minus ln of 2. Then if I solve it further, 2 times 2 ln 3 can be written as ln 3 square, which is ln 9, because I want the answer in format of ln a. So I'm just trying to convert the a ln b format to ln b power of a. So that is ln of just one term. So 3 square is 9 minus ln 4. Then ln 1 is 0. So I'm left with minus minus plus ln 2. And then this is equal to 2 times ln, because ln 9 is in the addition with ln 2, I can write this the same as writing 9 into 2. And because this is with the negative sign, I can divide this with 4. So what am I left with, guys? I'm left with ln of 9 into 2 is 18. 18 by 4. Let me check. So 18, let me just shift it to the normal mode. 18 by 4, what is the answer? Answer is 9 by 2. So ln of 9 by 2 square is what I am getting, and therefore this will be equal to ln of 81 by 4. Okay, so ln of 81 by 4 will become your final answer, where it is in the format of ln a, where a is a rational number in its simplest form. Okay, so I don't think so 81 can be divided by 4, but I'll just cross check it. 81 by 4, and yeah, that's it. So this becomes your final answer. Alright guys, so that's it for this video over here. If this video was helpful to you, if you want more such videos, then don't forget to click on the like button, subscribe to my channel for more such videos, and don't forget to write in the comment that I want more videos of P3, and I'll be coming up with some more content in the future.